Hi guys, in this video we're going to be talking about double focusing mass analyzers. And if you remember from my previous video or from your knowledge, a magnetic analyzer is going to take the ions, use a magnetic field using the velocity to centripetally force the molecule into this path. And if the ions mass is just right, because we know K equals 1/2 mv squared, we know that the just right ions will hit the detector. What I want to talk about in this video is an issue with that. And these mass analyzers are not taking into account Boltzman's distribution. Now, I'll bring up what that is again for those who have forgotten. Remember that if we plot temperature of molecules and the percent of the molecules, right? So if we have a random mixture of molecules that we assume are moving some speed, we measure the average kinetic energy to be like 70 kilojoules of kinetic energy. Well, it turns out these molecules are not following just one speed. They're actually distributed among a whole plethora of temperatures and thus kinetic energies. So what we observe is the maximum, right, where the most percentage of these molecules are at. However, some of the molecules can be going really, really, really fast or really, really, really slow. So how can we avoid this? Because this is not selecting for that. It's taking all of these kinetic energies and shooting it towards the detector, and because they all have the same mass, they're going to be hitting the detector, most of them. I would say probably, except for these like extreme outliers, maybe 2 standard deviations, all of these guys are going to be hitting the detector, right? And that's not good. We don't really want that, because what's going to happen is that we're going to get if we look at our signal, right, with respect to m over z, we're going to just see this huge, or I should say time, I guess, right? Time. You're going to see this huge broad band, and that's not good, because if you have ions of very similar size, you might overlap a peak. So if we, for example, restricted the amount of kinetic energy, and let's say we have 2 analytes that are very similar in their mass, right? You might be able to then resolve that peak that you're supposed to see, whereas here we didn't really see that. So double focusing instruments are typically a lot more preferred in relation to single focusing. So how do we fix that? Well, it's pretty simple. All we have to do is just select for this maximum temperature, or bring the amount of molecules that we're talking about just to the temperature that we are actually looking at, or you can think temperature or Ke. Okay, so we only want to encapsulate the abundant molecules. And there's a way that we can do this using an electric field. So we want to get rid of everything in red. We need to select out all of these ions. So how do we do this? Well, we just make a very simple modification. We still have our ion source, but we're going to first run it through an electric field. It's like, I think it's called an electrostatic analyzer. And then we bring it through just empty space, and then we have it run through a magnetic field. Okay, so we have a magnetic analyzer, and then we have this electrostatic analyzer. Okay, so hopefully you can see the 2 compartments, and then we're going to place our detector, of course, down here. So what is happening? Well, we have ions coming in this way, and they're at all different KEs. Remember, they have full Boltzman distribution of kinetic energy. Well, remember what a magnetic field is doing. It's going to be curving molecules, right? Because you notice that the electric field curves, so the field lines are going like this. So they're going to curve the path of ions coming through here. And if we put a slit at, dropped my chalk. If we put a slit at the end, well, let's say we have too slow of a molecule. Well, this ion, this very slow ion, let's actually draw this trajectory in red. It's going to go, but then it's going to get shoved by the electric field, and it's not going to make it through the slit. So that's the very slow bits being selected out. Okay, but what about the really fast molecules? Okay, well, they're going to go through, but they are going so fast that the electric field is hardly going to act on them, and they're going to slam into the top of the slit. So that's us selecting out the really, really fast molecules. Okay, but what about the just right molecules? Well, if we set the electric field to just the right strength, we can encapsulate, and this requires some trial and error, you can encapsulate the perfect trajectory. And what this looks like, if I grab this yellow chalk, it's going to be deflected perfectly into the slit. And we are encapsulating just one kinetic energy, and hopefully it's the most abundant, because if it's not the most abundant, well, you're going to get very bad signals, unless you maybe set your transducer or your amplifier to a little bit of a higher setting. But anywho, these ions get through the slit of a specific kinetic energy. They're going to continue a straightforward kinetic energy until they reach the magnetic analyzer. And when they begin to do that, you can assume it's literally just like a magnetic analyzer, and it's going to curve the path and hit the detector. So what do we do here? Well, if we considered before we would have got a very broad peak because of this Boltzman distribution if we had a signal over time, okay? However, what we did now, if we look at the after time and signal, okay, we're bringing this in, it's hitting the detector, now we're going to get a very sharp peak. Okay, very, very sharp peak. And it's just going to help our resolution, because remember, resolution is a function of the width of this peak. And if the width goes down, the resolution goes up. And thus, we get better resolved peaks. And again, this is helpful because if you have some very tricky stuff to separate, where you, let's say, for example, you're getting this, but you know you have 3 analytes in there. So you run it through a double beam analyzer. And instead, you're going to resolve those peaks, and you're going to get the 3 that you want. So that's why we use it, how it works, and why there is even a problem to begin with. So hopefully you enjoyed this episode. If you did, please drop a like, comment, and subscribe, and I hope that you have a wonderful day. Bye-bye.